Welcome to our deep dive into genetic algorithms. In this tutorial, we will learn what genetic algorithms are, how they work, and we will implement one step by step using Java. To get started, let's define what a genetic algorithm is. Genetic algorithms are a class of optimization algorithms inspired by the process of natural selection. They are used to find approximate solutions to complex problems through iterations of evolution. The basic idea behind genetic algorithms is to create a population of potential solutions to a problem. We will use a representation of solutions, typically called chromosomes, and apply genetic operators like selection, crossover, and mutation to evolve this population over generations. Now, let's set up a simple problem, maximizing a mathematical function. For this video, we'll optimize the function f(x) equals x superscript 2 where x lies within the range of 0 to 31. Let's outline our steps. 1. Create a population of random solutions, chromosomes. 2. Evaluate the fitness of each solution. 3. Select the fittest solutions for reproduction. 4. Apply crossover and mutation to create a new generation. 5. Repeat the process for a set number of generations or until convergence. Let's begin by creating a new Java project and setting up our classes. We will create a class called Genetic Algorithm to contain our main logic. Now, we'll define a class to represent an individual solution or chromosome. This will include the chromosome's genes and its associated fitness value. Next, we need a method to calculate the fitness of the chromosome. Since we want to maximize f(x) equals x superscript 2, we first need to convert the binary representation into a decimal value before calculating its fitness. Now that we have our individual class set up, let's create a population. We'll create a method in the genetic algorithm class to initialize a population of individuals. With our population initialized, we need a method to evaluate the fitness of each individual in the population. This method will calculate fitness and also keep track of the individual with the highest fitness. Now we need a selection process to choose individuals to be parents for the next generation. We will use a simple tournament selection method for this implementation. Next, we'll implement the crossover operator. We will use single-point crossover, where we randomly choose a point in the genes array and swap the genes between two parents to create offspring. Now, after we have created our offspring, we also want to apply mutation. Mutation helps introduce diversity into the population and prevent premature convergence. We will flip a gene with a small probability. At this point, we have all the building blocks in place for the genetic algorithm. Let's put this all together in our main method to iterate through generations and evolve our population. We've now got a functioning genetic algorithm. Let's test it out and see if it can effectively maximize the function we defined. In the console, you'll see the best fitness in each generation logged. After running the program, we should observe that over generations, the population evolves and the best fitness value increases, reflecting that our algorithm is learning and improving. Before wrapping up, let's discuss some potential improvements and variations you can explore with genetic algorithms. You might want to experiment with different selection methods, crossover techniques, and mutation rates. Additionally, consider scaling the algorithm to work with larger populations, more genes, or even complex problems outside mathematical functions, such as scheduling or pathfinding. That brings us to the end of today's tutorial on implementing a genetic algorithm in Java. Remember, this is just the tip of the iceberg. Dive deeper and experiment to unlock the full power of genetic algorithms. If you found this tutorial helpful, be sure to like, share, and subscribe for more programming tutorials. Drop your questions or suggestions for future topics in the comments below. Happy coding!